Capital Robotics has overcome the obstacle of high-priced robotic welding fixtures by working with OPTICAM to produce the ultimate fixturing software. The software basically guides you step by step through the process of producing custom fixturing for your robotic welding projects. Best of all, the fixtures produced can be cut from inexpensive sheet metal or even scraps. Either way, the outcome results in low-cost, precision custom fixturing to meet your needs precisely. And after you're done with your fixtures, they can be conveniently stored and used as needed. No other system offers this ability at any price.
Because Capital Robotics has developed a large market share of job shop or contract manufacturers in the Southeast, there's always been a dilemma of producing weld fixtures cheap and ineffectively without sending it to a machine shop and having thousands of dollars tied into low lot size parts. Camtech and Capital Robotics has co-developed a software package to help solve that issue. Let me run you through a quick demonstration of what we can do. So we have here is the fixture module. It's going to double click it. It's OPTICAM classic fixture design software. So once it pulls up, I'm going to kind of show you real quick fixture we have made already. So very common part is going to be a NEMA enclosure, a NEMA box. And as you can see, it's producing this a sheet metal fixture. Let me run you through real quick how to produce this. So if you look at the top, we have Fixture Wizard, and click it. So here's your box. It's going to be laid out in space. Basically, it accepts 3D solid models, IGES, step format. There's a couple different translators you can incorporate as well. And it's going to run you through a quick tutorial. So if you look at the top here, the fixture design module, we're on step 1 of 18. So basically, after 18 steps, some we may use, all of them may not need to be used. After all these are done, you can produce a fixture. So again, what it's asking you here is how do you want to lay on the robotic weld table? Defaults at 3 inches above the table, and then you can also change the angles if you like. So if you want to cant it 45 degrees towards the robot, you hit the value, hit the check mark, it'll cant it. But again, I want to put it in flat, so let's go back to where it was. I'm just going to hit next. So now it's going to be on step 2 of 18. And the box below here is just illustrations of the different parameters, the values you can put in on the top box. So again, now it's asking me what's the material type and material thickness you want to use for the fixture. So as long as it conducts electricity, of course, for grounding on a weld fixture, we can use it. You can do it in standard steel, galvanized, or aluminum for the different material types and then gauge types. You can also mix match the different blades. So the blades that hold upright can be one thickness and the base plate can be a completely different thickness. That's going to be able to achieve, so you can use remnants that you have in the shop, scrap material, it doesn't matter. Again, as long as it conducts electricity. So here's the 2 different material types we're using. I'm going to click next. So now it's going to ask you again a bunch of different parameters. How far outside the part do you want the fixture to extend? Inside the part, so on and so forth. And they're going to be illustrated with A, B, C, D, and then again down here at the bottom with what parameters are being changed. How far do you want the base plate to extend from the fixture? We can come back to that one in a minute. Some parts need to have a fake boundary put in with a solid model. If you want to nest multiple parts, how many in each direction and the spacing in between. So once you hit next, this step actually is where you input all the blades, the pitches. A represents one way, B represents the other. You can also input the values if you want for the spacing. I went ahead and clicked auto. It's going to automatically generate them. You can also move, shorten, extend, all sorts of different parameters you can do with as well. Go ahead and hit next. It's going to produce my grid pattern here, represented by green and purple lines. Then the next parameter we're showing is the hook, or the feet that can go at the bottom of the base plate. So basically, the way we designed this fixture, ours is going to have a tab. So again, you have the feature ability to put a hook on it. So each horizontal will hook into the base plate, and then when you add these green lines, they actually connect, and, sort of like an egg crate, and make everything work together. Let's go ahead and go to the next one. So the next part is where you can import Destaco clamps. The whole Destaco library is available on our website. You can import the solid models as well. And then when you bring them into the software, you put them anywhere around the part, click your mouse, and it's going to generate a tower with the same grid pattern to hold the clamp in place. And again, there's a parameters to go along with it as well. We're not going to use it on this fixture, so I'm going to hit next. Generic clamp rail on the side. So if you want to add a generic rail on the side, and then you can drill and tap and mount clamp wherever you like. Another feature. So right here, this is a very good feature. This was actually generated from a couple different customers we had making boxes like this. So you can put little bumps in the details, and what that does is, let's just say this part is 12 inches deep. If you had a flat surface going down the side of it on, just say, on all these blades, and once you weld it, it's going to swell up. You would need a crowbar to remove this part. So basically what we did was add these little bumps on the side, and you can determine what size they are and the distance between them. And then what it does, it gives you contact points. So now rather than having a flat surface that you have to beat the part out of, again, the contact points right here is what's locating your part. Another benefit is, of course, from solid models in a computer to real world tolerances, there's going to be a little bit of discrepancies. So what you can do is overcompensate these little bumps, make the fixture, make your part, bring it out to the weld shop, and then maybe you can file these down and grind them down to make up some of that tolerance, again, from the 3D world to real life on the factory floor. So we'll just go ahead and hit next. All right, the next option is if you have a larger fixture. This one's, again, is a little bit smaller. But if you have a large part, 4 feet by 8 feet, maybe these blades are made out of quarter plate, it's going to be a very large, very heavy fixture. So there's an option here. You can do some weight reduction, and it'll actually reduce the weight. So again, our contact points will still be there, but the weight is reduced, as well as if you're running in production, you don't want your fixture to generate all sorts of heat input to the part. So again, reducing the material thickness, or the material there, will reduce the heat input into the fixture itself. I'm click next. All right, so the next one, again, if you're a fabricator, you know this is true. Different punches on your press brake will give you different radiuses on your bend, so you can actually put a relief cut in it. That way, if the guy on the shop floor, has a different die width on the press brake, it's still going to fit in the fixture correctly. So you can kind of overcompensate for the bend radius. And click next. If you had a common feature in a part, so let's say there was a couple holes here and you wanted to locate a family of parts, maybe all your holes are the same, but maybe this part grows in the X or the Y incrementally every quarter inch or whatnot. But there's a common hole feature. You can also locate the product on that hole feature. That's what this screen's for. All right, click next. On Fusion Arc Weld Cells, we have the option on our Matrix table tooling tops. We have a common base plate hole pattern. Ours is 3-inch centers. You can mimic, again, the holes every 3 inches, what diameter, how many holes. If you just want to go around the periphery of the fixture or on the whole fixture, you can also do that as well. We have that option installed. And how do you want to preview the part? Wireframe or solid model? New solid body. And then what's nice, if you're laser cutting these fixtures, you can actually put where you can etch the material type or the part number, the date, any kind of description of what you want on there on the corner of the base plate as well. So let's go ahead and preview the fixture. Right now it's generating my different solid bodies. So this is what you have. Again, V's for vertical blades, H's for horizontal blades, and it will actually etch this onto the blade itself. So if you had, in this case they're all the same details, but if you had multiple details of different styles, it'll give you a roadmap. You'll have V3 here on the base plate, you'll see a V3 etched as well on the base plate. So again, now that you have all your pieces cut, you can assemble it. If everything looks good, which I think it does, we can go to the right over here now. Go ahead and create the fixture. And now what it's going to do is going to create all my DXF files. All my slots, tabs, holes. Basically, here's the fixture we've produced. If you look at the side here, there's some clips. So basically, you'll cut 4 of these clips out, and the distance actually in between here is for stacking these parts up. So if you took all these blades out, put 2 clips on each side, that's what these are kind of for, a storage clip. So if you can actually disassemble the fixture and put it on the rack. So if you had a larger part, you can imagine the amount of real estate it's going to take to hold this fixture on the rack. Well, if you can disassemble it, yeah, you may have 4x8, but it's only going to be maybe 2 or 3 inches thick. So again, it's for space saving as well. So once this is all complete, export the DXF. Let's go ahead and put it on my desktop. It's going to create a folder. It's going to tell you some of these are identical, and you're complete. Here's my folder for parts. So again, once the fixture is complete, you go ahead and cut it on your shape cutting. Again, plasma cut, water jet, laser, punch. We've created fixture for this NEMA box.